We're going to take a look at drawing the Lewis dot diagram for an atom. So on this sheet right now, you have a Bohr model for each atom. Notice that the Bohr models contain all the electrons in each atom. Well, we're going to take a look at the Lewis dot diagram for atoms. And when we draw the Lewis dot diagram, we are only going to include the valence electrons, which are the electrons in the outermost ring. So for example, if we're going to draw the Lewis dot diagram for lithium, we'll take a look at the Bohr model for lithium right here. Lithium has 3 total electrons, but when we draw the Bohr model for lithium, we're only going to include that 1 electron that's in its outermost ring, like that. So notice, here's the Lewis dot diagram for lithium, and instead of including all 3 electrons, it only includes that 1 electron in the outermost ring. Okay, the second rule when we're drawing Lewis dot diagrams for atoms is to spread the electrons out as if there's a square around the symbol. So we'll take a look at beryllium for this. Beryllium has 2 electrons in its outermost ring. So when we draw the Lewis dot diagram, we're going to draw those 2 electrons and we're going to spread them out as if there's a square around the symbol. So notice the first electron is drawn as a dot at the top, and the second electron is drawn on the side here. The same thing is true for boron and carbon. Notice that boron has 3 dots in its outermost orbital. And so for the Lewis dot diagram for boron, we're going to draw 1 at the top, 2 on the side, 3 at the bottom. Carbon's the same. We'll draw 1 electron at the top, 2 on the right, 3 goes on the bottom, and 4 goes on the left. Now, when we hit nitrogen, we actually have 5 electrons in the outermost orbital. And so we're going to come across the situation where we'll have an electron on all 4 sides. So that 5th electron, we're going to pair like that. Notice that I have electrons 1, 2, 3, 4 spaced out just like I did on carbon. That 5th electron now is going to pair at the top. Number 5 goes there. The same goes for oxygen and fluorine. Notice oxygen has 1, 2, 3, 4. The 5th electron for oxygen pairs at the top and the 6th pairs at the side. Fluorine has 1, 2, 3, 4. And then the 5th electron pairs at the top, 6th on the side, 7th on the bottom. Now, neon does the same thing, but something special happens with neon. Notice, neon is full. We have electrons on all 4 sides of neon, and we have a pair of electrons at each spot. So this model is full. Our Lewis dot diagram cannot hold any more electrons. The next electron that's added will kick us into the 3rd energy level. So neon has what we call an octet. It means its outermost electron ring is full with 8 electrons. That's what we call a completed octet. When a completed octet happens, the atom becomes incredibly stable. Neon is not going to react. It's not going to form compounds. It's not going to form ions because it has a completed octet. Fluorine, for example, is missing an electron. And so fluorine is going to be extremely reactive, especially with anything that's going to give fluorine its last electron that it needs. Okay, that is how you draw Lewis dot diagrams for an atom.